Are you ready to talk about this one? Okay. There's two approaches to it, and I'm going to go through the longest approach first, and then I'm going to go back and remind you, if you would remember your parent functions, ultimately your graphs in the end become a whole lot easier. Okay? So, to determine the vertical asymptotes, we have to make the bottom 0. To make the bottom 0, we need to factor. So you would rewrite this as x, and then x parentheses x plus 3. Which then creates a common factor on the top and the bottom. So we scratch that out, and ultimately all I'm graphing is f of x equals 1 over x plus 3 with a hole when x equals 0. So why is there a hole when x equals 0? Well, you take your common factor, whatever it is, and in this case it is x, and you set it equal to 0. So, different problem, but I think if I write it this way, it'll make more sense to you. So, if I had x plus 2, x plus 2, x plus 3, and I scratch out the x plus 2, I would still be graphing 1 over x plus 3, but when does x plus 2 equal 0? When x equals negative 2. So here I would have with a hole when x equals negative 2. So the reason that is 0 is because 0 is what makes that common factor 0. Okay, so it's not always 0. Okay? All right, so that's gone. So now, because I have a hole, I want you to always address that first, because what happens is we kind of tend to forget about it. Because we have a hole, that messes with our domain. X cannot equal 0. We're going to plug that 0 into our function. So what is 1 over 0 plus 3? 1/3. So I am going to go to my graph, and I am going to draw a hole at 0, 1/3. I've dealt with it in my domain, I've dealt with it in my graph, and then I can just kind of forget about it. I'm done with that. I don't have to worry about it anymore. So if you take care of it up front, you can just forget about it, and it's done. Okay? So now we're just going to move on. Pretend this was the problem I gave you. We're going to pretend it's at the beginning of the class period yesterday. So I would say, okay, what's going to create my vertical asymptote? X equals negative 3. So remember, that means x cannot equal negative 3, right? So I'm going to come to negative 3, and I'm going to draw my vertical asymptote. Horizontal asymptote is the degree of the top same, smaller, or bigger than the bottom? Smaller, which means horizontal is automatically y equals 0. Can my asymptote, can y'all see if I write right here? Can my equation equal my asymptote, which is 0 over 1? So if I cross multiply, I get 0 equals 1. So can it? No. And since my asymptote is the x-axis, and it can't equal my asymptote, which is the x-axis, are there any x-intercepts? No. Y-intercept, is it already marked on my graph as a hole? So I've taken care of intercepts and asymptotes, and now I'm ready to graph. How many pieces should I have to my graph? 2. Because I have one vertical asymptote, I have 2 pieces. Okay? So plug in something to the left. So let's try negative 4. So if I do 1 over negative 4 plus 3, I would get 1 over negative 1, which is negative 1. So at -4, I have a dot at -1. Since it can't cross, if the 1 dot's below, it's the whole thing below. All right, then plug in something to the right. Let's say -2. So 1 over -2 plus 3 would be 1 over 1, which is 1. So I would have a dot at -2, 1. Can't cross. So since the dot is above, everything's above. When you get to the hole, just pick up your pencil, skip over your hole, and then start going again. All right. Now let's look at my domain. It can't be 0 and it can't be -3. So it is -infinity to -3, -3 to 0, and 0 to infinity. Look at your graph. What are the y values that it can't be? Can't be 0, so y can't equal 0. Where else is it removed? 1/3. Y cannot equal, because at that point it is a whole. Okay? So my pieces would be -infinity to 0, 0 to 1/3, and then 1/3 to infinity. All right. That's taking it the long approach. You can't change this part. Factoring out the x, we get to here, we address our whole. Okay? But if I am thinking, once I address my whole, so I go ahead and I put my whole there, and now I look at what I am graphing. Whoops. Isn't that the parent function moved left 3? Okay, so all I have to do is 1, 2, 3 to the left for this asymptote. We know that this asymptote is going to stay at 0 because we didn't move it up or down. Because it's that parent, we pretend this corner is 0, 0, and we put a dot at 1, 1, and -1, -1. And then I don't have to worry about plugging numbers in. But it's okay if you don't recognize it as the parent, you're going to still end up with the same graph. This just allows you to get there a little bit quicker. Okay? So, we have pretty much now addressed everything. It can't cross it, it can cross it, and it creates a hole. Those are all of the things you have to think about. Now, what creates that hole? Having a common factor on top and bottom. Okay? All right, so that takes care of that. Now, we have a lot of things to talk about today. And just keep that piece of graph paper handy because we're going to do some more graphing momentarily. Will you get to what was your homework last night, the 1 through 28? And just keep all of those papers I gave you on your desk because I'm going to talk about them in a moment. Okay. Part of the confusion from last night's homework is y'all were always trying to look at these 12 graphs, and that wasn't the instructions. So, 1 through 12, you had to match with A, B, C, D. 13 through 18, it said use exercises 1 through 12. But over here it said refer to the 12 basic functions, which means you should have been looking at these pictures. And that is why when you're looking at the answers they gave you, they don't make sense because you were looking at transformations over here, not the original parent functions. Okay? So, words like extrema. This is an extrema. Increasing means my finger is going up. Decreasing means my finger is going down. Minimum, maximum, step, discontinuous. Okay, so those are all of those words they're talking about in there, but they're looking at these pictures. So the first thing I want to ask you to do is this weekend, re-look at questions 1 through 28, making sure you're looking at the right graphs. Okay, 1 through 18, you're using these. Starting at 19, you've got to flip backwards. All right? Then look at your answers, look at the graph, put stars by the ones that still make absolutely no sense, and we'll talk about those on Monday. Okay? I don't think we need to talk about all 28 questions, and that's going to be a waste of y'all's time. But put stars by the one that still make no sense to you, and I'll answer those questions on Monday. All right? You're right here, correct? Watch. Turn. And we're going to look at these 4 problems, and we're going to do them on the graph paper that you should have on your desk. So we're going to look at 45, 46, 50, and 51, and we're going to use the graph paper that you have on your desk. Okay. So, on 45, you are being told to graph f of x equals x when x is less than or equal to 0 and x squared when x is bigger than 0. What is that? F of x equals x. Parent line. Identity. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, right? What is that? Parent parabola. Right? But I only want to graph the parent line from 0 to the which direction? Left. Right? And I want to graph the parent parabola from 0 to the right. So all you're doing is putting 2 pieces on the same graph. These are called a piecewise function because you have different pieces. They're called a piecewise function. So here's my graph. I want to start 0, 0, 1, 1, but I want to go to the left. So would it be 0, 0, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3? And there's f of x equals x for x less than or equal to 0. Okay? Now I want to graph f of x equals x squared. So I want the right half of my parabola, correct? And I want to start it at where? 0. So y'all all think because it says greater than 0, you want to jump to 1. You don't jump to 1. You start at 0, but to exclude it, you put a what? Open circle. Okay? Because it doesn't jump from 0 to 1. It starts at 0.1, 0.11, 0.11111. So you have to start at the 0. If I plug in a 0, I get what? 0. So that would tell me to put an open circle there. But if on the same dot you have a closed circle, closed wins. So you don't open what is already closed. So it stays closed. Then I plug in my 1. 1 squared is 1. 2 squared is 4. 3 squared is 9. And I draw the right side of my parabola. Continuous or discontinuous? Continuous. Increasing or decreasing? Increasing. Bounded or not bounded? Not bounded. There's not a bottom and there's not a top. Are there any local extrema? No. There are no local extrema. Okay? Now, let me try to reiterate the open and closed circle just a little bit here. So if this instead had said x squared plus 2, I would take my parent parabola and move it what? So at 0, 2, I would have an open circle because the 0 is not included. At 1, I would have a 3. At 2, I would have a 6. At 3, I would have an 11. So that would be missing, and it would look like that, which would make that graph discontinuous. And because that's a hole, it is a removable point of discontinuity. An asymptote is a non-removable, but a point is a removable point of discontinuity. Okay? But when you have closed and open on the same place, it stays closed. It stays closed. Okay? 46. What does it want me to graph first? X cubed. When x is less than or equal to 0. Then it wants me to graph e to the x when x is bigger than 0. So I'm doing the parent x cubed. Remember, x cubed looks something like this. I'm doing the parent x cubed from 0 to the left. And then I'm doing exponential, which looks something like that, from 0 to the right. From 0 to the right. Okay? All right. So if I start at 0 and I plug in a 0, I get a what? 0. Then I plug in -1, and what do I get? -1. Then I plug in -2, and what do I get? -8. And then I'm not going to plug in -3 because then it would give me -27. Do I know enough about x cubed, or am I supposed to know enough about x cubed to know to kind of draw that piece looking something like that? All right. Do we agree parent exponential hovers right here and then goes up?
Yes.
All right. So I'm going to start at 0. If I plug in a 0, what is e to the 0 power? 1. But that circle should be open. E to the first, you should know that e is 2.7 something. So at 1, are we 2.7 something? And then we are not going to know beyond that. I don't know what e to the second power is, but I know enough to know that that is exponential, so is my pen just going to slowly go up there at like a curving motion, not a linear motion, correct? So I'm just going to kind of connect those and just keep curving it up because that's my exponential. I don't expect y'all to have lots of points on E and LN. I just want you to have the general shape of E and LN. If it was a 2, y'all could raise 2 to the second power, and you could raise 3 to the second power. Okay? Continuous or discontinuous? Would we consider that jump? Yes. This point is removable because it's a hole. Okay? 50. What does it want me to graph first? Absolute value. And then what does it want me to graph? Parabola. So I want the left half of the V and the right half of the parabola, correct? So absolute value of 0 is 0, but because it's not included, we make it open. Absolute value of -1 is 1. Absolute value of -2 is? Absolute value of -3 is 3. So is that the left half of my V? Now I'm going to do the right half of my parabola. 0 squared is? So because that one has an equal, do I close my whole in? Closed over open, open over closed, closed wins. 1 square it is. 2 square it is. 3 square it is. Continuous or discontinuous? Continuous. Bound it below. This piece is decreasing. This piece is increasing. This would be considered a minimum. That would be considered a minimum. Is that helping y'all with some of the words that you're seeing in those problems? Yes, ma'am.
What is like the local?
Well, I have to disagree with the way the book answers them, because they're calling this a local extrema, but it's really not local. I mean, it is the extreme minimum. And so basically just be able to tell me whether this is minimum or maximum. Now, if I have a graph that does this, this is definitely local maximum or local extrema. This is definitely local minimum or local extrema. So I disagree when the book in its example called that a local minimum, because technically it's the absolute minimum. So they're kind of, in their examples, they're kind of wishy-washy in how they're writing it. Main thing is to understand high point, low point, and if it definitely keeps on going, you for sure want to refer to these as local. But extrema is just where it's making that curve. Okay? All right. Number 51. How many pieces? Is negative x minus 3 equivalent to negative 3 minus x? And if I write that as negative x minus 3, doesn't that mean a line with a y-intercept of negative 3 and a slope of negative 1? Or the parent line shifted down 3 and reflected over the x-axis? Most of you do not graph lines by transformations. You graph them by y-intercept and slope, and that's fine. Okay? And then I want to graph just 1. What is y equals 1?
Straight line.
Well, all lines are straight technically. So try another word. Horizontal line. All right? And then I want to graph x squared, which is a part of a parabola. Okay? So here I want to go less than or equal to 0. Here I want to go between 0 and 1. And here I want to go greater than or equal to 1. So I am going to start this line at 0, which is the y-intercept. So what's my y-intercept? Negative 3. And because 0 is included, I put a closed circle. And then I have a slope of negative 1, which would tell me to go down 1 and right 1. But I need to go to the left, so reverse both actions. So instead of down and right, I have to go up and left for my slope of negative 1. Because if I go down, I'm going to the right when this tells me I need to go to the left. Okay? So if you change directions, you have to change both actions, not just one of them. So does that take care of that piece? All right, now we're going to draw a horizontal line at 1. Where should the line start? Where should the line end? And what do I put on the 0 and 1? Open circles. So there's my horizontal line starting at 0, ending at 1 with open circles. Then I'm going to draw my parabola starting at what? 1. What's 1 squared? 1. So does that close that open circle? What's 2 squared? 4. What's 3 squared? 9. So do I have that piece of my parabola? Continuous or discontinuous? Discontinuous. Jump? Yes. Jump, because you have to jump. Removable. Right? Removable. So those are called piecewise functions because you graph different pieces. You graph different pieces. Now, the one that's probably the trickiest in pieces is your parabola. Because if you are not past your vertex or at your vertex, do you need to make sure you come down before you start going back up? So you might have to plug in extra points. But in this form, should y'all easily be able to recognize vertex? So like if I write x minus 1 squared plus 2, where's the vertex at? 1, 2. So if I'm starting at negative 1, do I need to come down to my vertex before I start going back up? So always kind of keep in your mind, I got to think about where that vertex is. And all of these was I only dealing with the right part of the vertex. Okay? All right. So remember, I want you to relook at 1 through 28, and we'll talk about questions on that on Monday. All right. Find the packet that says quiz, because that's the one I picked up first. Find the packet that says quiz. And do not freak out because it says quiz. It is in your hands. You can take it home. You can talk to your neighbors. I don't care. It's really just another version of a review. Okay? Circle these problems. Number 1. Number 2. And on number 2, scratch out the word and boundedness of. Scratch out the words and boundedness. Circle number 4 and scratch out E. Circle number 4 and scratch out E. You will have to deal with boundedness on your test, but you're only going to answer those questions if the graph is also made. So I am not, these you don't have to graph, you're just answering the questions, so I don't want you to worry about the boundedness because I'm not having you graph them. I think all of you are okay with a picture being able to tell me whether it's bounded above, bounded below, or not bounded. Okay, so that's why I'm taking that off. Circle number 8. Not 8, I'm sorry, not 8, 9. Circle number 9. Circle number 13. And circle number 14. All right. So, at this point, we have discussed the material in those questions. Try to see what you can answer. And I'm not telling you need to do all of this weekend. But if you happen to have more time this weekend than you're going to have next week, these would be the ones you want to start with. The other ones we really haven't addressed yet. You may or may not be able to do them, but these we have covered. Okay? All right. Go to the review. Go to the review. And I'm going to do the same thing. The numbers I'm going to give you are the ones that we have talked about so far. All right? Y'all ready? No? Everybody got the review now? 1, 2, 3, 4. 1, 2, 3, 4. Flip the page. 11, 12, 13, 14. 11, 12, 13, 14, and 17. And 17 is something we did last year. So I put 17 there to help to try to trigger that memory there. Okay? And we'll talk about it again a little bit more today. So 17. All right, whoa, time out. Time out, time out, time out. Again, I am not telling you that is something you must do all this weekend. I do have some specific problems that I want you to do this weekend. I gave you those because, like I said, many of you have more time over the weekend than you do during the week. So if you have time to start looking at them, the more you do ahead of time, the less you have to do next week. And the more you look at them before I talk about them, the more you know what you know versus what I know, and how I know how to ask you questions to get you to say the right answer. Okay? I will eventually work all of them, and if we don't get it done in class, it will be a video, and I'll scan in an answer sheet. All right. Now, can y'all get to what is considered the rest of the notes for this packet, since we still don't have tablets? So that should look like this. Okay, everybody got these? Just leave them sit on your desk for a moment, because what I'm going to talk about is not on there. I really don't think you need to write it down, because I really don't think it's anything that's going to be an issue. So just watch for a moment. If I give you the function f of x equals 2x, and g of x equals x minus 3, and I tell you to find f plus g of x, what am I telling you to do to those two things? Add them. 2x plus x minus 3 is 3x minus 3, right? Okay. What is f minus g of x? Subtract them. 2x minus x minus 3 would be x plus 3. Okay? F times g of x. 2x times that is 2x squared minus 6x. And then f divided by g of x would be 2x over, and you do not do anything to it. You do not do long division. You do not do synthetic division. You write f on top, g on bottom, period. Don't do anything else to it. But beside that, you need to tell me that x cannot equal 3. Okay? Now that is why I told you you did not need to write that down. This is the one that y'all try to make difficult. Okay? What if I do g divided by x? Then it's x minus 3 over 2x, and x cannot equal 0. All right? I'm not even going to put any of these on the homework, but I put a couple of these there, and the only reason I put them there is because I want you to continue to think about what will make that bottom 0. Don't try to simplify this mess. Don't try to divide it. Write f on top, g on bottom, and tell me what x cannot be. That's all I want you to do there. Okay? Now, what we do need to talk about is f, open circle, g of x, and g, open circle. So what is the difference between the closed circle, which is multiplication, and the open circle? It's compositions of functions. So remember, this means, because I like to write it better like this, f of g of x, and this means g of f of x, which means we put a function into a function. So if I was going to do f of g of x, does that mean take this and replace x with x minus 3? F of g of x. And if I was going to do g of f of x, does that mean take this and put it in place of 3? So 2x minus 3. All right? So open is composition, closed is multiplication. All right. So now that's where I'm at example 3. So I'm now looking at your notes, and f of x is x squared minus 1, and g of x is the square root of x. and it says to find G of F, and then it says to find F of G. Okay? Everybody with me? G of F and F of G. And this is written on the paper so you can follow along, or you can rewrite it yourself if you want. Remember, this means G of F of X, which means F needs to go into G. So this needs to go everywhere there's an X, so it would become the square root of X squared minus 1. Nope. That stays the square root of X minus 1. X squared minus 1. Because if you factor X squared minus 1, remember it's X plus 1, X minus 1. So you don't really have 2 of something. Okay? To do F of G of X, then I'm going to take this and put it in place of X. So I have the square root of X squared minus 1. Well, they don't always simplify them, but I think it makes it easier for y'all if y'all actually simplify them. What is the square root of X squared? X minus 1. And here's why I say that. Because what does it follow right after the instructions? Let F of X be blank and G of X be blank, and then what does it say? Find the domains. What is this? A line. What is this? A mess. What is the domain of a line? All real numbers. So did it make it a whole lot easier once you made it a line? Now, unfortunately, it's not quite that simple. But that simplifies what you need to do. So in order to find the domain of this, I have to look at two things. I have to look at F because I am putting F into G, and then I have to look at my final answer. So I have to look at F and G of F of X. So F is what? What is F? A parabola. And what is the domain of a parabola? All real numbers. But this is a square root where this piece has to be greater than or equal to 0. Didn't we talk about this problem for the last 2 days? X squared minus 1. So this has to be greater than or equal to 0. What's the magic number I can square and subtract 1 from it and get 0? 1. And then 2, 3, 4, 5. Or negative 2, negative 3, negative 4, negative 5, right? So F has a domain of all real numbers. This has a domain of negative infinity to negative 1. Well, 1 to positive infinity. That's that problem we talked about yesterday. I didn't just come up with it today. Remember, we have to talk about what makes this 0. And when you put them together, it's an and, not an or. So if I say I must see Tessa and Cody in the hall, do I have to have them both out there? Yes. But if I say Tessa or Cody, Tessa comes fine, Cody comes fine, both come fine. All right? So if I must satisfy this, if I can be anything, but I have to satisfy this, this wins and this goes away. Because it's an and. I must satisfy both conditions. So I can't be everything when I have a restriction here. Okay, so this wins as my final domain. This wins as my final domain. Because you're only going to write domain one time, but you have to look at both of them to get to the final domain. Now, if this was all real numbers and this was all real numbers, what's my final domain? All real numbers. Okay? Now, if we come over here, I have to look at who first? It's the one you plug in. I have to look at G. Well, G is the square root of X. So X has got to be greater than or equal to 0. Okay? Then I come down here. This is a what? A line. What's the domain of a line? All real numbers. So I have to have every real number and be greater than or equal to 0. So who wins? Greater than or equal to 0. That's your actual answer, but you have to look at both pieces in order to get to that answer. You have to look at both pieces in order to get to that answer. Okay? So, if f of x is 1 over x, okay, and g of x is x plus 3, what is f of g of x? Do I put that there?
1 over x plus 3.
Right? So it becomes 1 over x plus 3. What's the domain here? All real numbers. What's the domain there? Down here, x can't equal negative 3. So all real numbers, so it's every number except negative 3. All right, please don't go to where, I need to circle some problems. I need y'all flip, please, really quickly. 2 pages, 116. Start at the bottom of the page under exercises, not quick review. Number 5, number 7, 12, flip it over, 12, 13, 15, 16, 17, 19, and 21. 15, 16, 17, 19, and 21. That I need you to do this weekend if at all possible, okay?